Hello again. As promised, we're moving from posing a specific question to figuring out how to answer the question. Study design is too big for one podcast, so here's part 1, the continuum. In this podcast, we're going to explore the continuum of research. This may be a new concept to many of you, but this continuum represents the larger research ecosystem in which our work exists. Understanding where along this continuum you are will potentially influence your design choices as well. Step 1 is exploratory research, and this is the very beginning of the continuum. It exists at the point where you have a galaxy-style question. Even as you refine the question to something specific, you may not know enough to create a testable hypothesis. So you need to gather some data in order to ask a better question. The purpose of exploratory research is to generate hypotheses that can be tested in subsequent experiments. Pilot studies often fit into this area, as would experiments that create or validate a research model. While this area is a really important step, one of the hurdles that work of this nature faces is the ability to convince people to fund it, because it's not always immediately applicable work. Step 2 is hypothesis testing, and this is the classic research model that many of us associate with clinical science. Think back to our specific question from last podcast. Does plate osteosynthesis lead to shorter time to radiographic union in skeletally mature adults smoking marijuana at least once a week with a 100% displaced mid-shaft clavicle fracture compared to those treated by optimal non-operative methods? Our hypothesis might be that the marijuana smokers have a longer time to radiographic union with non-operative treatment compared to plate fixation. We'll cover creation of statistical hypotheses in a separate podcast, but our resultant study will be designed to reject or not reject our null hypothesis. Stated correctly, it would be that there is no difference in time to radiographic union between the plate fixation and non-operative groups. This category of the continuum is where most, quote, original research lives. This type of research is chasing novel findings and is often quite a bit sexier than its neighbors on the continuum. Step 3 is confirmatory research, and this is the ugly middle child of the research continuum and has historically been severely undervalued to the detriment of science as a whole. If you follow science in the media, you'll be aware of a crisis in confirmatory research that has been forming up for a couple of years now. So what's the deal? The whole point of confirmatory research is not to do something novel. It involves recreating the conditions of a previously performed experiment and running it again to see if the same results are obtained. There are a few reasons why this is important. First, by the very nature of statistical inference, you'll expect a certain number of positive results to be due to random chance. Therefore, a second positive experiment adds weight to the notion that this is in fact a real result. Second, an initial very positive result will typically not have the same large effect size on replication. The statistical underpinnings of this reality is beyond the scope of this podcast, but multiple replications will bring us closer to truth in this instance. Because this type of research is not about novelty, nor will it bring the performer a promotion or a Nobel Prize, it has been neglected, and funding bodies and journals tend not to value it highly. Hopefully this will change as we understand its value in greater detail. A really good example of confirmatory research is in Coker's papers on septic arthritis diagnostic criteria. In the first paper, where he devises the criteria, the predictive value is very high. In the subsequent paper, where the 4 criteria are applied to a new patient population, the predictive value is lower. Look these articles up for yourself and see. Step 4 is synthesis, and it comes into play once a body of work has formed around a research topic. There may be multiple related research questions, similar but not quite the same experimental designs, and potentially conflicting conclusions. The goal of synthesis research is to take these single data points, evaluate their quality and significance, and stitch them into a larger tapestry of understanding regarding the overarching research question. The principle is that by taking a larger body of work and interpreting it, we get closer to the true answer. This is a type of research that you'll meet early in your residency as you go through the Surgical Foundations research course. There are several flavors of synthesis research in existence, many of which are relatively new. These include a traditional narrative review, a systematic review where evidence is evaluated for bias and attempts to capture unpublished data are made, a meta-analysis where pooled statistical inference is attempted, And finally, a scoping review, which is a new concept that fits somewhere between traditional narrative reviews and systematic reviews. Step 5 is translational research. This is the point at which you take your synthesized conclusion and get the information to the people who need to implement it and the patients who will benefit from it. This is a very new field in research, and it is still defining itself and its role. There is substantial overlap between translational research and quality assurance quality improvement research. An example of translational research would be how best to communicate information about osteoporosis diagnosis and treatment from fracture clinic to patients and general practitioners to ensure that best practice is being achieved on a large scale. My general observation about work being done in the section of orthopedics these days is that most of the energy expended is being spent on the exploratory, hypothesis testing, and synthesis steps. It will be interesting to see if work increases in the other two areas as time goes forward and awareness of their importance increases. Understanding where your work fits into the research continuum is important because it informs on how you structure your experiment, how you pitch it to the regulatory bodies, funding agencies, and publishing bodies, and how you plan your own future directions. Ideally speaking, a successful research program will eventually traverse the entire continuum from conception to implementation on a wide scale. In summary, research is a continuum from initial question conception to application of robust findings to patients. It's important to keep this in mind both when you do research and when you read the research of others to ensure that you appropriately prioritize the strength of the findings and the conclusions being made. It's also important to keep in mind that a single experiment with a large positive effect should be interpreted with caution until the results are confirmed. Coming up, we'll continue down the study design road and touch on the specific design types and their advantages and disadvantages.